Every time you start your car, whether it's with a classic key or a modern push button, you're doing more than just getting ready to drive. You awaken its heart, the engine, a complex machine that instantly springs to life, ready to propel you forward. This core component transforms fuel into motion, powering not just acceleration, but also essentials like your air conditioning, power steering, and even the music you listen to. Without it, a car is just a metal shell, an impressive structure, but unable to move or serve its purpose. The engine is a symphony of pistons, cylinders, and valves, all working in harmony at incredible speeds, creating the power that defines your driving experience. Its design shapes a car's personality, whether it's built for thrilling speed, smooth comfort, or maximum efficiency. The engine is at the core of what makes each car unique. Beyond turning the wheels, it drives vital systems like the alternator, water pump, and more, ensuring every part of your car works together seamlessly. For over a century, the internal combustion engine has evolved through relentless innovation, adapting to new challenges and technologies. From simple single-cylinder machines to today's computer-controlled marvels, engines have defined automotive progress and shaped the way we travel. As we move toward electric and hybrid technologies, understanding the traditional engine helps us appreciate how far we've come and where we're headed next. The engine remains the beating heart of automotive history and innovation, a symbol of human ingenuity and our drive to keep moving forward. Most gasoline engines run on the four-stroke cycle: intake, compression, power, and exhaust. This process is the core of how your car transforms fuel into motion, and it's been refined over more than a century of engineering innovation. First, the piston moves down inside the cylinder, creating a vacuum that draws in a carefully measured air-fuel mixture as the intake valve opens. This mixture is the engine's raw energy source, and its precise ratio is crucial for efficient combustion. Next, the piston rises, compressing the mixture tightly against the cylinder head. This compression increases the potential energy of the mixture, setting the stage for a powerful release. At peak compression, the spark plug fires, igniting the air-fuel mix in a split second. This controlled explosion generates a burst of energy, forcing the piston downward with tremendous force. This is the power stroke, the heart of the engine's work. The piston is pushed down, turning the crankshaft, which ultimately drives the wheels and propels the car forward. Finally, the exhaust valve opens and the piston rises again, pushing out the spent gases left over from combustion. These gases exit through the exhaust system, making room for a fresh charge. This entire cycle repeats thousands of times every minute, seamlessly producing the continuous power that moves your car down the road, whether you're idling or accelerating. The precise timing and perfect balance of these four strokes are what make modern engines both efficient and powerful, allowing for smooth operation and maximum performance. Each stroke is essential. If even one is out of sync or missing, the engine can misfire, lose power, or fail entirely, highlighting the importance of every moving part. The four-stroke cycle is the foundation of modern automotive performance, powering everything from compact cars to high-performance sports vehicles. It's a marvel of engineering, happening faster than the eye can see, with countless parts working in harmony at incredible speeds. This is the heartbeat behind every drive, the invisible force that brings your journeys to life every time you turn the key. To make more power, an engine needs more air and fuel. Forced induction, using turbochargers or superchargers, packs extra air into the cylinders. Superchargers are belt-driven, delivering instant power, but using some engine energy. Turbochargers use exhaust gases to spin a turbine, boosting efficiency by recycling energy. Turbos can suffer from lag, but modern designs minimize this delay. Both systems let smaller engines produce big power and torque. Forced induction has revolutionized performance, making cars faster and more efficient. It's all about squeezing more energy from every drop of fuel. This technology is at the core of today's high-performance engines. Iconic cars like the Porsche 911 Turbo showcase turbocharging's power. Twin turbos and advanced tech like variable turbine geometry deliver instant, relentless acceleration. Turbocharging allows smaller engines to achieve supercar performance while staying efficient. Superchargers, as seen in muscle cars like the Dodge Challenger Hellcat, offer immediate throttle response. Their belt-driven design means power is always on tap, with a signature whine that excites enthusiasts. Superchargers provide linear, predictable power, perfect for drag racing and aggressive driving. While less efficient than turbos, their instant response is unmatched. Both systems have shaped the world of performance cars. Forced induction is the secret weapon behind modern automotive thrills. Petrol and diesel engines both use internal combustion, but in different ways. Petrol engines ignite a pre-mixed air-fuel blend with a spark plug, delivering high-revving, responsive power. Diesel engines compress only air, then inject fuel, which ignites from heat. No spark needed. This makes diesels more efficient and torque-rich, ideal for towing and long-distance driving. Petrol engines are lighter and more agile, perfect for city driving and sporty cars. Diesel excels in fuel economy and low-end power, but is heavier and revs lower. The choice depends on your needs, efficiency and torque, or lightness and quick response. Both have been refined for decades, each excelling in different roles. Understanding their differences helps you pick the right engine for your lifestyle. Hybrid and electric vehicles are transforming how we drive. Hybrids like the Toyota Prius blend a petrol engine with an electric motor for efficiency and instant torque. Regenerative braking recaptures energy, boosting fuel economy in stop-and-go traffic. All-electric vehicles, such as the Tesla Model 3, run solely on battery power and electric motors. EVs deliver silent, rapid acceleration and require less maintenance due to fewer moving parts. Charging replaces refueling, and range depends on battery capacity. The driving experience is smooth, quiet, and emissions-free at the tailpipe. As battery tech improves, EVs are becoming more practical for everyday use. The shift to electric is reshaping the automotive landscape. These technologies represent the future of mobility. Comparing powertrains comes down to efficiency, but there's much more to consider than just miles per gallon. Each type of powertrain brings its own unique advantages and trade-offs to the table, shaping the way we drive and experience our vehicles. Petrol cars average around 35 miles per gallon, making them a familiar and accessible choice for many drivers. Diesels, on the other hand, can reach 45 or more, especially on highways, thanks to their efficient combustion and higher torque. Hybrids, like the Prius, take things further, topping 55 metal pod G by blending electric and petrol power. This combination allows for impressive fuel savings, especially in stop-and-go city traffic where hybrids excel. Electric vehicles, measured in mpge, far surpass combustion engines. Tesla's Model 3 rates over 130 mpgz. This means you travel much farther on the same amount of energy, making EVs a game-changer for efficiency. EVs convert over 90% of battery energy into motion, while combustion engines waste most as heat. This fundamental difference is why electric cars feel so responsive and why they're so efficient. This makes EVs not only cheaper to run, but also more energy efficient per mile. Lower maintenance costs and fewer moving parts add to their appeal for many drivers. Each powertrain has strengths: petrol for agility and quick acceleration, diesel for towing and long-distance travel, hybrids for versatility and urban efficiency, and EVs for pure energy savings and quiet operation. The electric motor is the current champion of energy conversion, setting new standards for what's possible in automotive technology. The evolution from four-stroke engines to EVs is a story of relentless progress, driven by innovation and the pursuit of cleaner, more efficient transportation. The quest for better, cleaner motion drives automotive innovation forward, promising a future where efficiency and sustainability go hand in hand.